The most recent Leaf strategy regarding room experts has concluded that, with our latest $11 billion initiative, it will take an exceptionally long time before this mission becomes a reality. If everything proceeds as projected, the voyage to Proxima B is expected to span approximately 20 years. As a result, it will be a considerable time before we can speculate about the presence of life on that planet. The Deep Space Telescope has been pivotal in investigating whether or not we are truly alone in the universe, continuously providing supporting evidence through its discoveries. The James Webb Telescope has uncovered intriguing human-like objects far beyond Earth, bringing us closer to resolving this profound question. Our pursuit of life beyond Earth has been an ongoing drive embedded in all human endeavors, so much so that we have constructed countless theories and media surrounding it. Our fascination with our place and significance in the universe remains ever present, deeply ingrained in our nature to persistently seek out companionship, no matter how similar we may be. This drive pushes us forward and still looking for answers. Even if we do get closer, can we be certain these answers are truly what we seek, or are they simply distractions? Join us as we explore the gradual and persistent discoveries being made in the vast realm of galaxies and planets on a journey that could reveal something we might not be prepared to witness, the distant lights of other worlds. Scientists may have discovered the most important sign of extraterrestrial life in history back in 2021, when the James Webb Space Telescope was being developed. During this period, a bold and speculative inquiry arose regarding the potential of our technology. The critical question was whether, in the future, our telescopes could detect artificial light on distant exoplanets such as Proxima B, the closest exoplanet to Earth. Proxima B, located roughly 4.25 light-years away, was believed to be tidally locked, meaning one side is always facing its star while the other remains in perpetual darkness, similar to how our moon behaves. A potential technological breakthrough could make it possible to transfer energy from the day side of Proxima B to its night side, employing captured solar panel power from the starlight. A study led by scientist Manasvi Lingam and others demonstrated that an extraordinary combination of solar cells on the day side could be connected to future telescopes. This is particularly relevant today, as the James Webb Space Telescope has been developed and could allow us to extend our search for artificial light on exoplanets like Proxima B. In fact, the James Webb Space Telescope's ability to carry out this very task in 2024, utilizing its advanced resolution and capabilities, marks a major milestone. The telescope may have already detected the very lights we were hoping to find, possibly ushering humanity into a new era of scientific discovery. Let's dive deeper into the world of exoplanets and galaxies to understand how this extraordinary feat was made possible. The mission of the James Webb Space Telescope, JWST, to explore Proxima B is grounded in humanity's ancient curiosity about the universe. Since the dawn of recorded history, humans have speculated about our place in the cosmos, questioning who we are, where we came from, and where we are headed. These timeless yet profoundly challenging questions have been central to human inquiry for centuries. With the progress of modern technology, one wonders whether we are closer to answering these pressing questions. If you were to ask a philosopher, they might argue that we are only at the very beginning of truly understanding our existence in the universe. On the other hand, an astronomer would likely eagerly present the latest discoveries about the universe, utilizing state-of-the-art tools. Though often overlooked by the general public, these instruments are a direct reflection of human progress. We now have the universe laid out before us, and it's time for us to broaden our understanding and embrace the cosmos with confidence. One way to achieve this is through the efforts of astronomers and space experts, who have been crucial in the creation of new technologies to help discover potential signs of life on distant planets. The James Webb Space Telescope, a marvel of human innovation, is central to this mission. This infrared telescope has begun tackling these age-old questions, pushing the limits of what is possible in space exploration. You may be wondering, what exactly is Proxima B? Also known as Alpha Centauri Proxima, Proxima B is a super-Earth exoplanet that orbits an M-type star. To clarify, super-Earths are planets more massive than Earth but not as massive as ice giants like Neptune or Uranus. They are distinct in that they can be composed of gas, rock, or a mixture of both, and their sizes vary, some being twice the size of Earth while others may be several times more massive. Proxima B fits the definition of a super-Earth and is classified as an exoplanet because it orbits a star outside our solar system. The initial potential for an exoplanet was found to have evidence in 1917, though it didn't generate much attention. It wasn't until 1992 that confirmation came with the first verified exoplanet discovery, which astonished experts. Another exoplanet initially detected in 1988 was confirmed in 2003. As of April 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems, with 896 systems containing multiple planets. Many of these exoplanets orbit M-type star systems, commonly referred to as red dwarfs. These stars are the most prevalent in the Milky Way, but their low luminosity makes them difficult to detect, complicating our search for planets. Red dwarfs come in various classifications and names based on their size and temperature, such as M-dwarfs. Proxima B has a mass about 1.07 times that of Earth and takes just 11.2 days to complete one orbit around its star, in comparison to Earth's 365.25 days. The size of the star Proxima B orbits can be estimated by considering the full electromagnetic spectrum. The star's total luminosity is only 1.6% of the sun's brightness, and in the visible light spectrum, it shines at just 5 to 6% of the sun's intensity, emitting far less light energy. More than 85% of its energy output is infrared radiation, ranging from 0.045 to 0.056 Australian dollars from its star. Proxima B's discovery was officially announced in 2016, but what sets it apart from the thousands of other planets in our galaxy? There are several reasons why astronomers are particularly focused on Proxima B. It is the closest known exoplanet to our Sun, and while 4.2 light-years may seem distant, in the vastness of the universe, it is relatively close. Proxima B is part of the Alpha Centauri star system, a triple star system. Despite its low brightness, it remains one of the brightest objects in the night sky, trailing only Sirius and Canopus. Researchers in this field act like skilled detectives, scanning radio signals for faint whispers of intelligent life beyond Earth. This endeavor began in the 1960s when the renowned astrophysicist Frank Drake first detected radio waves from distant stars. While extraterrestrial visitors have yet to arrive, the search continues. The quest for extraterrestrial signals demands patience, often spanning decades or even centuries. Few definitive signals from extraterrestrials have been found, but the pursuit continues to inspire hope, particularly as the James Webb Space Telescope gathers data from planets like Proxima B. This expanding field of exploration could someday lead to the confirmation of extraterrestrial life, or perhaps ambiguous signals that leave us with more questions than answers. Regardless, the detection of light or signals from distant worlds such as Proxima B could mark a monumental step in humanity's unrelenting search for life beyond Earth. With the rapid advancement of technology, our ability to detect and analyze exoplanets is improving exponentially. New telescopes and observational techniques are making it possible to examine planetary atmospheres, searching for biosignatures, chemical markers that could indicate the presence of life. Scientists are particularly interested in the presence of gases such as oxygen, methane, and carbon dioxide in specific ratios, as these could suggest biological activity. Furthermore, upcoming space missions aim to explore exoplanets more directly. The proposed Habitable Worlds Observatory and the LUVOIR, Large Ultraviolet Optical Infrared, telescope could provide even greater clarity in detecting potential life-supporting environments. Meanwhile, next-generation space probes may one day visit Proxima B or other nearby exoplanets, sending back unprecedented data about their composition and conditions. As we stand at the edge of a new era in space exploration, one question remains: are we truly alone? If we do find evidence of life beyond Earth, it could fundamentally change our understanding of our place in the cosmos. Until then, the search continues. One signal, one discovery, and one step closer at a time. Curiosity, where the intersection of knowledge and technological progress leads to an exciting adventure in the cosmos. As we continue in our search, we hold out hope that one day we will discover conclusive evidence that we are not alone in the universe. The discovery of artificial lights or other signals from distant exoplanets, such as Proxima B, would be a groundbreaking step toward providing an answer to one of humanity's fundamental inquiries: are we the only ones in the cosmos? As the James Webb Space Telescope continues its mission, its findings will undoubtedly ignite further discussions, research, and possibly even challenge our understanding of life, intelligence, and the very nature of the universe. The potential ramifications of these discoveries go much further than curiosity. The possibility of confirming existence on another exoplanet, such as Proxima B, would compel us to re-evaluate our place in the universe. Could life on other worlds evolve similarly to our own, or would it take a completely different form? Would these life forms follow familiar patterns of growth and development, or would they defy everything we know about biology and consciousness? Even if we do not find direct evidence of intelligent life, the mere detection of artificial light or signals from distant planets would still carry profound implications. It would mean that intelligent civilizations potentially exist elsewhere in the universe, capable of altering their environments in ways that we can understand. This would suggest that intelligent life is not a rare phenomenon but a natural outcome of specific conditions in the cosmos. However, as exciting as this potential discovery may be, we have to approach it cautiously. The confirmation of extraterrestrial life brings with it numerous questions, including how humanity should respond. How will we react to the discovery of intelligent life? Will we approach it with respect, curiosity, and scientific rigor, or will these revelations provoke fear, panic, or even political conflict? History has shown that groundbreaking discoveries, especially those that challenge long-standing beliefs, can provoke unpredictable responses. As we venture deeper into space, it is vital to think about the moral and ethical implications of our search. If we do discover life, particularly intelligent life, on another planet, what responsibilities do we have as caretakers of Earth? What ethical guidelines should govern our interactions with other forms of life, whether microbial or advanced? There may not be simple answers to these questions, but they will undoubtedly be important to the ongoing discussion as humanity continues to make its way into the stars. The search for life beyond Earth, driven by instruments like the James Webb Space Telescope, is an exciting intersection of science, philosophy, and humanity's future. The findings and questions raised by the James Webb Space Telescope as it explores exoplanets like Proxima B will significantly shape humanity's understanding of the universe. Its search for artificial light on distant worlds, particularly in the habitable zones of stars like Proxima Centauri, is one of the most ambitious undertakings in the quest for life on other planets. The possibility of uncovering extraterrestrial civilizations is a concept that both excites and challenges our perception of life beyond Earth. The excitement of discovering artificial lights or signals from faraway planets may seem like the final frontier, but it is only the beginning of an entirely new chapter for humanity. Moral and philosophical dilemmas tied to such discoveries cannot be ignored. How should humanity approach the possibility of encountering extraterrestrial intelligence? Would we seek communication, or would we exercise caution in fear of the unknown? Could the discovery of another intelligent species spark new global collaborations, or would it foster division and conflict as various factions around the world navigate the implications of such a revelation? The way we respond to such moments in human history will inevitably shape the future of humanity. Another important consideration is the broader scientific implications of this search. The detection of artificial light on a distant exoplanet would not only imply the existence of intelligent beings but also reveal how life can adapt and survive in different environments. It may challenge our assumptions about the necessity of conditions we consider essential for life, such as water or carbon-based molecules. The potential diversity of life forms, their technologies, and even their environmental impact could expand our understanding of life's potential across the cosmos. Yet, while the quest for extraterrestrial life is undeniably exciting, it must be grounded in humility. The universe is vast and mysterious, and even if we find signs of life, they might not necessarily resemble anything we expect. Life could take forms that are so fundamentally different from our own that it may be difficult for us to recognize or comprehend it fully. The search for life on Proxima B and similar exoplanets is a journey of discovery that will force humanity to confront its own place in the universe, not just as a species capable of great technological feats, but as one that must learn to respect and understand the broader cosmic context in which it exists. As we move forward into this new era of space exploration, we must also consider the broader implications of our actions. The technologies we develop to detect distant signals and artificial lights could also become tools for understanding our own planet's challenges. The knowledge we gain about distant worlds may offer insight into how to better control Earth's environment, offering us new perspectives on environmental and energy sustainability. Our findings may also lead to new scientific breakthroughs, not just in astronomy but across a wide range of fields, from biology to physics to engineering. Ultimately, the search for life beyond Earth is not merely about finding evidence of other civilizations, it is about better understanding who we are, where we come from, and what the future holds for humanity. The James Webb Space Telescope represents a pivotal step in this search, with its capacity to look further into the universe and deeper into the mysteries that have captivated humanity for centuries. But as we embark on this incredible journey, we must remain conscious of the larger ethical, philosophical, and scientific questions that will shape the future of this exploration. The discoveries we make could transform our understanding of life itself, altering our perspective on the universe, our place in it, and the future of our species. As we stand on the precipice of these potential discoveries, we must also prepare for the broader societal impact they may have. The confirmation of extraterrestrial life, whether microbial, intelligent, or somewhere in between, would not just be a scientific revelation but a cultural and existential one. How would different societies, religions, and philosophies interpret such a discovery? Throughout history, humanity has often reacted to paradigm-shifting revelations with a mix of wonder, skepticism, and resistance. The realization that we are not alone in the universe could prompt new religious and philosophical discussions, challenging long-held beliefs about our uniqueness and purpose. Would this discovery unite us as a species, fostering global collaboration, or would it deepen divisions as different groups interpret its significance in conflicting ways? Moreover, practical considerations would come into play. If we were to detect signals or artificial structures from another civilization, how should we proceed? Would we attempt communication, despite the uncertainties and risks involved? What if the civilization is vastly more advanced than we are? The history of first contact between human cultures on Earth often serves as a cautionary tale. Unbalanced encounters have frequently led to exploitation and conflict. Could the same dynamics apply on a cosmic scale? Another critical question arises: if we detect signs of life, should we visit? The ethical concerns surrounding planetary exploration are complex. There is a growing awareness of the need to prevent biological contamination, both from Earth to other worlds and vice versa. The introduction of Earth-based microbes to an alien ecosystem could have unintended consequences, just as the potential exposure of humans to extraterrestrial microorganisms could pose risks to our own biosphere. Beyond the immediate scientific and philosophical questions, there is also the issue of how such a discovery would influence future space exploration. If we find evidence of life on Proxima B or another exoplanet, it would likely accelerate the development of interstellar travel technologies. New propulsion methods, space habitats, and long-duration space missions could become priorities, driven by the desire to learn more and, perhaps one day, make direct contact. However, even if such contact remains far beyond our current technological reach, the mere knowledge that life exists elsewhere would change how we see ourselves. It would redefine what it means to be human, expanding our understanding of life's potential diversity and resilience. It could also offer us new insights into our own survival. If other civilizations have emerged and persisted, what lessons can we learn from them? Conversely, if we find only remnants of past civilizations, it may serve as a stark warning about the challenges of long-term survival in a vast and often hostile universe. The search for extraterrestrial life is ultimately a search for understanding, about the cosmos, about life's possibilities, and about ourselves. The James Webb Space Telescope and future missions will continue to push the boundaries of our knowledge, bringing us ever closer to answering one of the most profound questions in human history: are we alone? Regardless of the outcome, the journey itself will transform us. It will shape the future of science, philosophy, and human identity, reminding us that the quest for knowledge is one of the most defining aspects of our species. As we look to the stars, we are not just searching for others, we are searching for ourselves.